Okay, guys, I've had a lot of questions about today's assignment. There were several of you, or more than several of you, that actually said you're having some trouble. So let's take a look at each one of these problems. I'll go slowly through the solutions. I'll do my best to explain them. Um, on Monday, you'll have more of the same type of problems. So hopefully, after watching the video today, and maybe watching the video again on Monday, possibly if you need some help, you'll be a little bit more successful with similar type problems on Monday. All right. So let's take a look at this first problem. It says to find the area of the figure, we want to use 3.14 for pi, and we want to round our answer to the nearest tenth. Well, there's two areas, right? If we want to find the area of this figure, we need the area of the rectangle. Let's call that area 1. And we need the area of the semicircle. Let's call that area 2. So we're looking at essentially two different areas. Area of the rectangle and the area of the semicircle. And by finding the area of these two figures and then adding the two areas together, that's going to give us the total area of the figure. So let's start with the easy area, area 1. Area 1 is going to be equal to the length times the width because it's a rectangle. So area 1 is going to be equal to 15, right, times 30, right, because they're the length and the width. So area 1 is going to be equal to, what's that, 450, and those are square meters. Right, now that's just the area of the rectangle, which is 450. We then have to find the area of the semicircle, right? And we're going to call that area 2. Area 2 is going to be equal to pi times the radius squared, which is the formula for the area of an entire circle. But because it's a semicircle, we're going to take half of that area. That's why we're going to divide that by 2. So area 2 is going to be pi times r squared, but then we need half of that area. All right? So area 2 is going to be equal to, well, we're told to use 3.14 for pi, so I'm going to replace pi with 3.14, and we need the radius of this circle. Well, how do we find the radius? Well, let's look at our picture, right? If we're looking here, right, imagine, right, that's the entire circle. The radius is going to be half of this distance. Well, I know this total distance is 15, so what is half of 15? Well, it means then that our radius is going to be half of 15, which is going to be 7.5 meters, right? We need the radius to find the area of a circle, and the radius is going to be the distance from the center to the edge, right? So our radius is going to be half of that 15, right? Because the diameter of the circle would be 15. The radius is going to be half of that 15, so 7.5. So let's go back to this problem. So that's going to be 7.5. We're going to have to square that, and then we're going to have to divide that by 2. So area 2 is going to be equal to, now when you're using your calculator, we have to do the exponent first. So when we do this calculation with the calculator, we have to take the 7.5 and square it. Well, with your calculator, 7.5 squared is the same as 7.5 times 7.5. That's going to give you 56.25. So normally I wouldn't write this step, but I'm going to write it just so that you guys could see it. So this is 3.14 times the 56.25, and then we're going to divide that by 2. 7.5 squared is not 7.5 times 2. 7.5 squared is 7.5 times 7.5. That's where we get the product of the 56.25. So now, area 2, we can finish this with our calculator. Multiply 3.14 times that 56.25, and then we want to divide all of that by 2, and we wind up with 88.3125. 88.3125. Now the total area of this figure is the sum of area 1 and area 2. So you'd write something like this. The total area is going to be equal to area 1 plus area 2. So that's going to be 450 plus the 88.3125, right? That decimal point shouldn't be there. Right, so let me erase that. I gotta erase that decimal point. So that should just be 3125. Right, so it's 31, oops, Let's do that. That should be 3125. All right, and when we add that together, plus the 450, we wind up with 538.3. Right, and that's our answer. The area is going to be equal to 538.3 if we round to the nearest tenth. Those are square meters. Right, these are square meters. And it looks like that would be which answer? That's going to be answer B. So problem number 1 should have had answer B. Let's look at our next one. We want to find the area of the shaded region, round our answer to the nearest tenth. Well, the area of the shaded region this time is going to be the area of this rectangle minus the area of the semicircle, right? Because if I like to do this, and I did this during the lesson. All right, so I'm going to take this here, and let's get our highlighter, because I like to use that. All right, if we highlight this whole thing here, let's shade this whole part in. Right, there's my rectangle, right? And I'm looking at that area, the area of the rectangle. If we find the area of this rectangle, then take away, all right, that's what I'm going to do now. I'm going to take away the area of the semicircle, right? And taking away the area of the semicircle, that's subtraction. We take away the area of the semicircle, what's left is the area that's shaded. So that's what we want to do mathematically. We want to find the area of the rectangle, which is pretty easy, find the area of the semicircle, which is not that hard, and then we just want to subtract those two areas, right? So those, that has to be our steps. So let's start with, call this area 1, call this area 2. We're going to find those two areas and then subtract. Area 1 is going to be equal to length times width because it's a rectangle. So area 1 is going to be equal to 6 times 5, right? So that's 6 inches times 5 inches. So area 1 is going to be 30 square inches. Right? Now that's the area of that entire rectangular space there. That's going to be 30 square inches. Now we have to find area 2, which is the semicircle. So area 2, I'm going to use the same formula we used for the last problem, pi r squared, but because it's half of a circle, we take half. So area 2 is going to be equal to 3.14 times the radius. Well, what's the radius here? Well, the diameter of the circle is 5 inches. So if the diameter is 5, the radius has to be half that. So the radius is going to be 2.5 inches. And that's what we need to do the problem, right? So that's going to be 2.5 inches, but we have to square that. Then we divide that by 2. All right? So area 2 is going to be equal to 3.14 times, we're going to do 2.5 squared first, so that's 2.5 times 2.5 if you're using your calculators. So that's 6.25 when we take 2.5 and we square it. Then we have to divide that by 2. So let's do that. So that's times 3.14 times 6.25. We want to divide that by 2. Wind up with area 2. It's going to be 9.8125. Those are square inches. So we want to subtract the two areas. So shaded area, our shaded area is going to be equal to area 1 minus area 2. So that's going to be the 30, take away the 9.8125, and we wind up with 20.1875, and those are square inches. If we look at our answers, they're probably rounded to the nearest tenth. All right, and what would 20.1875 round to the nearest tenth? That's going to be answer A, right? 20.2. Right, so 20.2, answer A for question number 2. All right, so just take your time with these problems. They're not that hard, but those were two of the tougher ones. All right, now these next couple are a little bit more straightforward. So problem number 3, we're just looking for the area of the circle. Right, so area is equal to pi times the radius squared. Because we're looking for the entire area of the circle, we'll use 3.14 for pi. Now the radius is going to be half of this diameter. The distance across is going to be 47, so my radius is going to be half of that distance. So with your calculators, you can take 47 divided by 2. but that's going to be 23.5 for the radius, and we have to square that. All right, so we could just write r is going to be equal to 23.5, right? That's going to be this distance here, half of the diameter. So with our calculator, the next step, area is going to be equal to 3.14, and we have to do 23.5 squared, which is 23.5 times 23.5, and that's going to be 552.25. And then so our area is simply going to be the product of that. So area is going to be equal to 3.14 times the 552.25, and we wound up with 1,734. Now, with my calculator, I get 0.065. Now, let me just explain that, right? Because we see that the answer is D, because that's the closest answer. But why the difference, right? Why isn't this going to be 0.1 and that's 0.9? Because it depends what you're using for your approximation for pi, right? We use 3.14 for pi, but sometimes your calculators or computers, they'll use a different approximation for pi. It might be 3.1415 something, right? There are more decimal places, so it's going to give you a little different answer. So when you do a problem like this, you want to choose the answer that your answer is closest to using 3.14, and that would be answer D, and these are square centimeters. So for problem number 3, we should have answer D. Alright, question 4, right? Another straightforward problem, even easier because we're given the radius this time. So area is going to be equal to pi times the radius squared. So area is going to be equal to 3.14. Now my radius is 7, and we're going to square that. So area is going to be equal to 3.14 times 7 squared, which is 49, because that's 7 times 7. So my area is going to be equal to 3.14 times 49. We wind up with 153.86. These are square meters, and that would be answer B would be our closest answer. So for problem 4, we have answer B. Okay, let's try problem 5. The drawing is composed of a rectangle and a semicircle. Find the area of the figure to the nearest 10. Well, this is similar to problem number 1. So we want to split this into two shapes. Call this area 1, call this area 2. Area 1 is a rectangle, area 2 is a semicircle. So we're just using those two formulas, right? Area 1, we're going to use length times width because it's a rectangle. So area 1 is going to be equal to the 18 times the 10. Right? So area 1 is going to be equal to 180. These are square centimeters, right? That should be 180. I want to make that a little neater, right? So that should be 180 square centimeters. Area 2 is a semicircle. So area 2 is going to be equal to pi times r squared, but because it's semicircle, we need to take half of that area, right? Because the area of a circle is pi times the radius squared, but we're not finding the area of an entire circle, we're finding the area of a semicircle, which is half of a circle, so we have to take our formula for area and divide it by 2. So area 2 is going to be equal to, we'll use 3.14 for our approximation for pi. Our radius is what? Well, let's see. Well, we're told this distance here, right, is the same as this distance here, so that's 18. So what's the radius? Well, the radius is going to be half that distance, so our radius here is going to be equal to 9 centimeters, right? So that's what we have to use for our r. So that's going to be 9 centimeters, but we're going to have to square that. Then we have to divide that by 2. So area 2 is going to be equal to 3.14. Now 9 squared is 81, right? Then we have to divide that by 2. So we're going to do 3.14 times 81, and then we have to divide that by 2, and we wind up with 127.17. So area 2 is going to be 127.17. These are square centimeters. Now the total area is going to be the sum of area 1 and area 2. So the total area is going to be equal to area 1 plus area 2. So that's going to be 180 plus 127.17. Right, and that's going to be 307 square centimeters. So we get 307, what's that, 0.17 square centimeters. That's our area. And we want to choose the closest answer because of our approximations for pi. And that's why that would have to be answer C. Alright? Alright, let's look at number 6. We're looking for the exact area of a circle. For problem 6 and 7, we're going to write our answer in terms of pi. Alright, so that's a little weird, a little different, right? But it's rather simple actually. So area is going to be equal to pi times r squared. So area is going to be equal to, writing our answer in terms of pi means we do not use an approximation for pi. So we're not going to use 3.14 for pi. We're going to keep pi as pi. But the radius squared is going to be 3 as our radius, and we square it. So the area is going to be equal to 3 squared, which is 9. 9 times pi would be our area. Now I know that our answers here, right, we had both answers were the same, right, and that's just a mistake on the computer's part, and that's all right. But that's where we get the 9 times pi inches squared as our answer, right? Want to have my units inches squared. So it should be 9 times pi inches squared. Right, so let's try this one. Here the answers are different, right? So let's take a look and see what this is going to be in terms of pi. Area is going to be pi times the radius squared. So the area is going to be pi times the radius. Well, what's the radius here? Well, we're given the diameter is 3. Radius is half that diameter, so our radius is going to be 1.5 inches. So that's going to be 1.5, it's going to be squared. So we take our 1.5 and we multiply that by itself, 1.5, and we wind up with an area of 2.25 times pi square in inches. And that would be answer A for question 7. So I know it's a little different for us to do or to write a problem or to find the area in terms of pi, but as you get older, a little bit further in your math, that's going to happen more and often. It's going to happen more often because when we approximate pi, we're getting an approximate answer. When we write our answers in terms of pi, like we are here, we get an exact answer, and that's important in mathematics to have an exact answer as opposed to an approximate answer. All right, let's look at our next example, problem 8. It says a field is to be fertilized at a cost of 8 cents per square yard. The rectangular part of the field is 95 yards long and the diameter of each circle is 49 yards. Find the cost of fertilizing the field. Use 3.14 for pi. All right, so if we read carefully, we're told the distance from here to here is 95 yards. We're told that the diameter of each semicircle, so the distance from here to here, is 49 yards. So we have to find the area of two different figures. Area 1, we'll call that the area of the rectangle, right? So I'm going to highlight that in red. Area 1, we'll do that in red. But then area 2, we're going to do in green. Area 2 are your, area 2 are your two semicircles here. Well, what happens when you put two semicircles together? Well, two semicircles are the same or equivalent to one full circle. All right, so we'll call that area 2. Area 2 is going to be the area of a circle. All right, so let's start with area 1. Area 1 is going to be equal to length times width because it's the area of a rectangle. So area 1 is going to be equal to 95 times 49. Right, so area 1 is equal to, well, let's do that with our calculator. So we want to do 95 times 49 times 49. We wind up with 4,655. And those are square yards. Okay? And then we look at area 2, right? Area 2 I'm going to do in green. Now, area 2, we said, is the area of a full circle. So that's going to be pi times the radius squared. Because we have a half a circle here and a half a circle here, 2 semicircles equal 1 full circle. So we just want to use pi times r squared for area 2. Area 2, we're going to use 3.14 for pi, because that's what we're told here in the problem. And then our radius is going to be what? Well, if the diameter is 49, the radius is going to be half of 49. So what is half of 49? That's going to be 24.5. Then we have to square that, because it's pi times the radius squared. So area 2 is going to be equal to 3.14. But then we have to multiply 24.5 times 24.5. That's going to give us 600.25, right? And you guys, please, right? And you see what I'm doing here with when I'm squaring my radius. I write the product of that power, because that's a good habit to get into, and that's where I see some of you making mistakes when you're submitting your work. So area 2 is going to be equal to 3.14 times 600.25. That's going to be 1,884.785. Those are square yards. Well, now we need the total area. So I'll write my total area is going to be area 1 plus area 2. So it's going to be area 1 plus area 2. So my total area is going to be equal to, let's see, 4655 plus the 1,884. That's going to be 6,539.785. These are square yards. That's the total area. But then we're told what in the problem? The field is to be fertilized at a cost of 8 cents per square yard. All right, so I want to take each of these square yards, and then we want to multiply this, right, by the cost for each square yard. So we want to multiply that by the 0.08, and we wind up with 523.1828. But if I'm rounding that to the nearest cent with money, that's going to be $523.18. Now, let's see. Is that one of our answer choices, $523.18? Right? Yes, it is. Right? So we wind up with answer B for number 8. Now, that's a great question, right? But honestly, it's not that hard, guys. You're just finding the area of a rectangle, then you're finding the area of a circle, you're adding those two areas together, and then you're multiplying that by the 8 cents for each square yard. So yes, it's several steps, and you have to be organized with your information, but once again, right, look at what we did for that problem, and you come up with the correct answer of $523.18. All right, just a couple more to do. All right, problem number 9. I thought this was a cool problem too, so I wanted to have you guys play around with it. The diagram shows a square of a side 3 inches. Right, so we know these are 3. Right, those are 3 inches. Right, these are 3 inches. Containing a circle with a diameter of 3 inches. To the nearest hundredth, what is the area of the shaded part of the figure? Right, and that's just that little piece here. So notice what we've done with some of the other problems. We've split the figure into parts, right? And then we found the area of each part. We either added or subtracted. Here we're going to have to find the area of the entire square. Then we're going to have to subtract the area of the circle. And when we subtract the area of the circle, right, let me draw this out so we could see it. These are going to be our steps. All right, first, we're going to have to find the area of the circle, right? So let's do that first. Let's do that now. So we're finding the area of the entire square. So area 1 is the square. So area 1 is just going to be, let's write the formula. area 1 is equal to the length of the side squared. So area 1 is going to be equal to 3 squared. So area 1 is going to be 9 square inches. Now that's that whole thing there. Alright? Now, next we find the area of the circle. The area of the circle is going to be pi times r squared. Pi times r squared, let's call this area 2. So area 2 is going to be equal to 3.14 times the radius. Well, the radius is going to be half of this diameter. The diameter is 3, so our radius is going to be 1.5. So it's going to be 1.5, but don't forget to square it. So with our calculators, you want to do 1.5 times 1.5. Right? So area 2 is going to be equal to the 3.14 times the 2.25, right? Because that's 1.5 times 1.5. Right? And then you multiply those two and wind up with area 2. It's going to be equal to 7.065. All right? Now the next thing we want to do is subtract area 1 and area 2. Right? So I'm going to take 9 and I want to subtract the 7.065. Right? And watch what happens when we do that. Right? When we subtract 9 and 7.0625, that's going to be oops. That's going to be equal to 1.935, right? And those are square inches. But let's see what we just did there visually, right? When I subtract the area of the circle from the area of the square, this is what we're getting. This is what we're doing, right? I subtract and I get, let me be careful here, try to leave it, I get this, all right? And look what we've done. When we subtract the area of the circle, we have 4 of these sections, right? That's the area that's left when we subtract the area of the circle from the area of the square. We only want 1 of these sections. So what do I have to do with this number to find 1? Right now we have 4. We only need 1. So I have to take this number here and do what? What do you think? All right? Yeah, we're going to have to divide that by 4. So when we divide that by 4, that's where we wind up with the 0.48375. Those are square inches. We round that to the nearest tenth, and that's where we get answer, right? That's where we get answer A when we round to the nearest tenth, right? Because we have to divide that by 4. So they gave us 2 answers, right? Because this answer here would be all 4 of those sections, but when we divide by 4, this is what we're doing. We're getting rid of, right, 3 of these when we divide by 4, right? Because that's what's left when we divide that by 4. So that's really kind of a neat question, and that would be our answer. All right, and then let's do our last one. Right, this one's a little bit easier. Right, very similar to some of the other ones we've done. Call it area 1. Call it area 2. Guys should be getting used to these by now. It's about the 3rd one we've done. All right, so we'll call area 1. This time area 1's our semicircle, so that's going to be pi times the radius squared, but we're going to divide that by 2 because it's a half a circle. So area 1 is going to be equal to 3.14 times the radius. Well, the diameter of the circle is 8, so the radius is going to be half that. It's going to be 4, but then we have to divide that by 2. 4 squared is 16, so area 1 is going to be equal to 3.14 times the 16, but then we're dividing that by 2. Alright, so let's do that. 3.14 times 16, press equals, divide that by 2, and we wind up with area 1. It's going to be equal to 25.12. Those are square centimeters. Area 2 is the rectangle. That's the easy one. Area 2 is going to be length times width. So area 2 is going to be equal to 3 times 8. So area 2 is going to be 24. Those are square centimeters. So the total area is the sum of those two, right? So the sum is going to be, right, the total area, right, is actually going to be area 1 plus area 2. So that's going to be 25.12 plus the 24, and that's where we get 49.12 square centimeters. and to the nearest whole number, that's where we get answer A for question 10. All right? Guys, we had a lot of good problems in there last night, right? I wanted you guys, or today actually, I wanted you guys to take a look at them and really give them your best effort. But this is what your work needs to look like, guys. Go back and look at the slides. I'm going to provide the PDF for this so that you could see all these problems worked out, right? But look at how the problems are worked out. I'm going to give you guys probably 10 more problems Monday that you could practice and that you could try, right? Do your best with it. And then hopefully, Monday, all of these problems will be a little bit easier for you because you've had a chance to see how they were done, and then you guys can try these on your own. All right? I hope that's been helpful, and we'll see you soon.